For this question, I'm going to take the long way to the answer. Because I think if you understood it, you know where shortcuts are going to be possible and you're just going to kind of do them. But if you're a little confused, I think it's better to take the long way and guarantee yourself the points, and that way you understand why the answer is the answer. But in both cases, you need to get started from the same place. And that is recognizing that that phrase, no solutions, is really important. It is not a throwaway kind of term. It is an essential part of the question. So what does it mean for a system of equations to have no solutions? Well, a solution is a point of intersection. So if they don't have any points of intersection, when does that happen? Well, with lines, it only happens when the lines are parallel. And when are lines parallel? When they have the same slope. And I know these are lines because they do not have any exponents on the variables. But they don't quite look like lines the way I want them to. Normally, right, I would want it to be y equals mx plus b, and then I care about the m's being compared. And this is where, if you know some shortcuts, you can kind of get there faster, just knowing the patterns that are going to take place. But I am going to be thorough and just trust in y equals mx plus b to get me to where I need to be. So I need to see equations where the m's are the same. So I would take that first one, and the first thing I would do is say, ugh, fractions are terrible. Let's just multiply everything by 4 to get rid of the fractions. So 4 times 3/4 gets rid of the 4 on the bottom and leaves me with 3x. 4 times a half is going to get me negative 2y, and that's equal to 48. Now that's easier for me to rearrange and get into y equals mx plus b form. So I would subtract the 3x, and I would get negative 2y is equal to negative 3x plus 48, and I would divide by negative 2 to get that y is equal to 3/2 x minus 24. And yeah, it's a little messy with the 3/2, but that is okay. That is my slope. So now what I want is I want my other equation to have that same slope. So what I would need to do now is change this into y equals mx plus b form. And it's a little more annoying because the a and the b are kind of also part of this, but that's why we get in the habit of doing this process so that when things get a little weird, we've got the right motions built in. So ax minus by is equal to 9. I'm going to subtract ax. I'm going to get negative by is equal to negative ax plus 9, and then I divide by negative b to get y by itself, and I have y is equal to a over bx minus 9 over b, which is weird, but here's the thing, with parallel lines, y-intercepts don't matter. In fact, we don't want them to have the same y-intercept because then they wouldn't be parallel lines, they would be the same line. So we only need the slopes to be the same. So in this case, we need 3/2 to be the value of a over b, because a over b is in the m position of this other line. And it's not a coincidence, I don't think, that they're asking for a over b. That's the slope, and so we're just done. 3/2 is our answer, 3 over 2, or 1.5. You could bubble it either way. But yeah, that's it. That's the whole question. So the shortcut could have come about in different places if you see that the relationship between 3/4 and a and negative 1/2 and negative b is kind of the same. And so we could have kind of just made our fraction of a over b right from the start. If you didn't see it though, y equals mx plus b gets you there anyway. And it's not that much slower. I'd rather you get the points than not get the points, so take your time and get those 10. But bigger picture too is I don't know what another harder version of this question looks like. I could absolutely see the SAT creating a version of this where you can't take that shortcut. And so I'm a little nervous teaching it and getting you in that habit if it's not always going to work. Whereas this version, where we're literally looking at the slopes of the lines, should get you the answer every time, because it's getting back to a place where everything makes sense. All the basics are there. The slope is the slope. It's hard to just, see it as anything different. So I don't have a specific example where they've done that, but I am nervous that the shortcut could make you fall for a trap on another version of this question. So just file that away. Just be on the lookout. You never know. Slow and steady wins the race. That's kind of my motto for the SAT.